We discuss compound inequalities and absolute values, we'll be combining what we've talked about in the last two sections and putting together an absolute value in an inequality. But first, let's talk about these compound inequalities. Compound inequalities, when you take two inequalities and put them together using something that we might use in English to make a compound sentence. Those words are words like and or. So here I've combined two inequalities using the word and. There's a very fundamental difference between the word and or in English, just like there is in mathematics. So let's first look at the compound inequality using the word and. The word and you should literally think about as an intersection. It's what the two sets have in common. So you can really see the difference when you look at the graph of the solution set. And you notice that you want to combine and look at the intersection of y is greater than 4 and y is less than 7. And the solutions that these two inequalities have in common, where they intersect, is the solution set for this compound inequality. But what happens when you look at the word or? The word or is used to mean the union of two sets. So when we put two sets, the solutions to each set together, it creates the solution to the compound inequality. And again, it's very easy to see when you look at it graphically, because x is less than -1 or x is greater than 4. And we put both solution sets together in the exact same solution to answer this compound inequality. So when we come back to putting our absolute value and inequality together, let's first review that when you are looking at an absolute value equation, don't forget that we want to set up two separate equations to solve this absolute value equation. Two equations are 2x minus 2 equals 4 and 2x minus 2 equals a -4. Same thing is going to be done here when we're dealing with an inequality, but whether this absolute value is greater than 4 or less than 4 is going to make a huge difference whether we use a compound inequality of and or. So let's take a minute to look at the difference between the absolute value of 2x minus 2 is greater than 4 and the absolute value of 2x minus 2 is less than 4. Both are going to include a compound inequality as their solution. But how do we know whether we should be using the word and for an intersection or if we use or for the union? To answer that, we have to enter the gates of Gorland. Gorland is a mythical place that tells us whether we should use an and compound inequality or an or. The gates to Gorland tell us whether we should set up an or an and compound inequality. So as you can see here, if the doors look like an absolute value, while the handles look like inequalities. If the absolute value is greater than, like in this first example, 2x minus 2 is greater than 4, then we should set up an or compound inequality. But if the absolute value is less than, Gorland tells us to set up an intersection compound inequality. So here in this first example, because the absolute value is greater than 4, then I'm going to need to set up an or statement. So I will set up two separate inequalities. 2x minus 2 is greater than 4, or 2x minus 2 is less than negative 4. And now I'll solve each inequality separately. And now you can see that the solution set to this compound inequality is x is greater than 3 or x is less than negative 1. And when I graph this solution set, you can see that I want the union of the two because I'm dealing with an or statement here. So x is greater than 3 or it's less than negative 1. But now when I come over here to this other example where 2x minus 2, the absolute value of 2x minus 2 is less than 4, again, if I return to the gates of Gorland, I know that because it is less than, I want to set up an and compound inequality. So my two inequalities will be 2x minus 2 is less than 4 and 2x minus 2 is greater than negative 4. And again, I will solve each inequality separately. So here my solution is an and in the intersection of x is less than 3 and x is greater than negative 1. And once again, you can see when I graph the solution set, I want the intersection of what these two sets have in common.